Hi, my name is Hyung-Guk Seo, and I am PhD student at Visual Media Lab KAIST. Today, I'd like to share with you our work Overthere, which is a simple and intuitive object registration method for an absolute media pointing interface. With the development of technology, various kinds of new home devices have emerged. The increasing number of devices forces the user to manage diverse remote controls, causing much inconvenience. An absolute media pointing technique can be a promising alternative to interact with the devices in a smart home environment. Among the media pointing techniques, a free and point interaction would be the most intuitive and natural way to select a target. However, it is difficult to construct an environment where free and pointing is available. To enable free and pointing interaction, we need a camera that observes the user. And we also need a cumbersome preprocess called object registration. Then, what is the object registration? The absolute media pointing interface identifies the object pointed to by the user via raycasting. However, at first, the system does not know what and where devices are in the camera coordinate system. Object registration makes the system know what and where each device is in the camera coordinate system. In previous work, object registration was achieved by using conventional calibration techniques or high-tech hardware. However, these approaches are too complicated or expensive, which are not acceptable at an end-user level. To tackle this problem, we introduced Overthere, which is a simple and intuitive object registration method. The key idea of Overthere is a human-in-the-loop strategy. To identify object position, Overthere captures the multiple pointing gestures and calculate the intersection of those gestures. We regard the intersection point as the target position. By adopting this strategy, Overthere allows ordinary people to register a target object simply. Here is our user scenario. The registration starts with object type selection. In this step, the user simply selects the type of the device to be registered. Then, the user points to a target at multiple viewpoints, and the system captures the pointing gestures. A pointing gesture aimed at a target can be represented as a 3D straight line. The origin of the ray is the head position, and the direction vector is the head-hand vector of the user. When there are multiple pointing gestures, they do not intersect each other because they are skew lines. So we approximate a nearest point from all straight lines by using a least square method. Overthere, regard this point as a target position. After each pointing gesture, the user can confirm the registration result based on 3 types of feedback. The user can decide to accept or discard current registration by intuitively evaluating the current estimation result based on this feedback. As a result, the feedback ensures the user to achieve reliable registration results. Here is an example scenario in a smart home environment. The user first registers the devices using Overthere. After the registration is complete, the user can select the target devices with a pointing gesture. By utilizing other natural user interfaces such as hand gestures, the user can control the devices with free-hand interaction. We conducted 3 experiments to investigate the characteristics of our system. The goal of first study is to identify the optimal pointing motion that leads to accurate and coherent pointing results. Because our method utilizes human pointing gestures, the pointing gesture itself should be accurate and coherent for the accurate registration result. We compare the pointing results formed by 3 pointing motions. The experimental results showed that the ground motion is most accurate and coherent in a Kinect environment. The purpose of second study is to identify the factors that can affect the accuracy of the estimated position. The experimental results showed that the maximum angle between pointing gestures and size of the target affect the estimation error. Study 3 was carried out to investigate the performance of Overthere and effect of feedback on error and time. The average estimation error was about 19 centimeters and completion time for each device was about 28 seconds. The feedback improves the accuracy of estimation, but it makes the completion time delayed. This is it for the presentation. Thank you.